In this video, we're going to talk about taking samples from populations. A population is a group containing all of the people or things we want to draw conclusions about. Usually, a population is so large that it is nearly impossible to get information from each individual in it. To help fix this problem, we often use samples instead. A sample is a subsection of the population that we get information from and use to draw conclusions about the full population. So here we're using a sample to learn something about the population. So here's an example. Jeannie interviewed all the ninth graders at a high school about their opinions on cafeteria food. Is this a sample of the student population? So no, this does not describe a sample because she asked all the ninth graders. So that means it's not a sample because it's the entire population. So when we're taking a sample, it's only part of the population. A proper sample should avoid being biased. A biased sample occurs when those chosen to be in the sample don't reflect the full population. Having bias in a sample can lead us to drawing completely different conclusions from the ones we'd get if we surveyed the full population. One way we can avoid bias in our sample is through representative sampling. A representative sample in statistics is a sample that accurately reflects the characteristics of the whole population. It is like a miniature version of the whole population with similar demographics and traits. Here's an example. Elena asked each movie director whose movies have earned $100 million or more about the state of the movie industry. Is this a biased sample of all filmmakers? So yes, this is biased because she only asked directors who earned $100 million or more. And she was trying to make a conclusion about all filmmakers. So she missed out on all those directors, or on representing the directors who made smaller movies that made less money. So yes, this is a description of a biased sample. Here's another example. Lenny surveyed each of the school's volleyball team members about their thoughts on changing the school's mascot. Is this a representative sample of all the school's athletes? Well, no, this does not describe a representative sample because she surveyed the volleyball team, but was trying to make a conclusion about what all of the school's athletes think. By just asking the volleyball team, she missed out on some important viewpoints from the other athletes that might have different opinions and characteristics. And finally, a third example. Ananya asked people from each instrument section in a school band about getting new instruments. Is this a biased sample of the school's band? So no, this does not describe a biased sample because she's asking members of the band from each of the sections. So she's getting viewpoints from all sections of the band. So no, it is not biased. And in fact, we would say it is a representative sample. Now let's learn about using random sampling to avoid bias. Random sampling happens when we use some kind of random method to determine which individuals we survey. This way, we can say that no personal biases were involved in the conclusions we draw. For example, Parker interviewed his 5 favorite players on the soccer team, asking them about their opinion on this year's team. Is this a random sample of the soccer team? So no, this sample is biased because he asked his favorite players. So he wasn't choosing the players randomly. So no, it is not a random sample. He has introduced bias into his sampling. Here's another example. After writing down each student's name, John interviewed the ones he blindly drew from a hat about their opinions on their teachers. Is this a biased sample of the student population? So no, this sample is not biased because he is choosing the names randomly. He's picking them out of a hat. Next, we're going to look at 4 types of samples that can help researchers get representative and unbiased samples. First, we'll look at simple random samples. A simple random sample is a sample of a population in which each member of the sample has an equal probability of being chosen. Selection can be achieved through methods like random number generation or drawing names out of a hat. The advantages of simple random sampling. Well, this method is straightforward and considered the gold standard of sampling. The disadvantages are that it can be impractical or expensive depending on the situation. So in this example, we're wondering, is the following statement an accurate method to collect a simple random sample? Governor Lincoln wants to know what percentage of residents in his state support a new tax law. Instead of asking all the state's residents, he decides to survey a sample of 469 residents. He assigns a unique number to each resident. Then he uses a random number generator to select 469 residents for the sample. So yes, this is an accurate description of a simple random sample, because he is simply choosing names randomly out of a hat, or using a random number generator in this case. Now let's see if this example is a simple random sample. CEO Sandy wants to know about employee satisfaction at his software development company. Instead of surveying all his employees, he decides to survey a sample of 316 employees. He randomly selects one employee from a list and then selects every 5th employee after that until 316 are selected. So no, this is not a simple random sample. This is describing a different sample method we'll talk about in a moment. Now let's look at stratified samples. Stratified sampling is a method of sampling from a population that can be divided into subpopulations based on a shared characteristic. The population is divided into subgroups. These subgroups are called strata or stratum, and a random sample is taken from each subgroup. The point of a stratified sample is to ensure that the resulting sample is representative of the population. Examples of strata subgroups include age, gender, location of residency, occupation, marital status, household size. So for instance, if we want to make sure we have representatives from all age groups in our sample, we could break up a population into groups based on age and do a random sample from each age group, and then combine those into one larger sample. So in this example, we're wondering if the statement is an accurate method to collect a stratified sample. Principal Athena wants to know whether or not students at her school enjoy the tacos in their school lunch. Instead of surveying all the students, she decides to survey a sample of 103 students. She divides the students into groups based on their grade level. Then she chooses a random subset of students from each grade level, with each subset having a size proportional to the number of students in that grade level. Then she combines the subsets to form the sample. So yes, this is an example of a stratified sample, because she's choosing random samples from each grade and then combining those samples into a larger one. This way, she is assured that all grade levels are equally represented. Now let's learn about systematic samples. Systematic sampling is a method of sampling from a population that involves first selecting a random individual as a starting point, and then selecting every kth individual, like every fifth individual or every 10th individual, after that until the desired sample size is reached. The point of systematic sampling is to ensure that the resulting sample is representative of the population. If the population is in a random order, this can imitate the benefits of simple random sampling. However, the possible drawback of systematic sampling is that it can introduce bias if the list of individuals is ordered in a way that is not representative of the population. So in this example, we're wondering if the statement is an accurate method to collect a systematic sample. So Principal Bess wants to know whether or not students at her school enjoy the pizza in their school lunch. Instead of surveying all the students, she decides to survey a sample of 454 students. She randomly selects one student from a list and then selects every 13th student after that until 454 are selected. So yes, this is a systematic sample because she randomly selects a starting point and then selects every, in this case, 13th student after that until she has a large enough sample size. So that is a description of a systematic sample. And finally, we have cluster samples. Cluster sampling is a method of sampling from a population that involves first dividing the population into groups called clusters, and then randomly selecting some of the clusters to survey. Clusters are not selected based on a common trait, and thus each cluster should look like a small-scale representation of the entire population. The main benefits of cluster sampling are its cost effectiveness and convenience. So for instance, if we wanted a sample of airline passengers, instead of randomly selecting from all airline passengers, we could randomly select a certain number of flights and then survey everybody on those flights. So we're wondering if the following statement is an accurate method to collect a cluster sample. Governor Rose wants to know what percentage of residents in her state support a new education law. Instead of asking all of the state's residents, she decides to survey a sample of 169 residents. She divides the residents into groups based on the neighborhood they live in. Then she randomly selects 6 neighborhoods and then surveys all the residents in those neighborhoods. So yes, this is an example of a cluster sample because she's randomly selecting neighborhoods and then surveying all of the residents in each of those 6 neighborhoods. I hope this lesson about populations and sampling has been helpful. This is Mr. Ela signing off.